vectors, a geometric approach. So here's some notation. This represents a vector. You can also have a V with the arrow on top of it. That would also indicate a vector. And here's another example. If you just have a lowercase, that's a scalar. And if you have the absolute value bars on the side, that's the magnitude of the vector. So here's our first example. We got a boat crossing a river that runs due north. The boat is pointed due east, so the boat is going east while the river is going north. And the speed of the boat is 12 miles per hour. So that would be this direction. 12 miles per hour. And the river is going this direction at 5.1 miles per hour. And now we need to find the actual course of the boat through the water. So if the river is going this direction, then the actual boat is actually going to go in this direction. So I'm going to erase this over here, and I'm going to put the 5.1 on this side. It's the same thing, miles per hour. You have a right triangle. So the actual direction of the boat is this direction because even though it's going horizontally, the river is pushing it towards the north. So this is the actual path. So we need to find this angle and also the magnitude. So let's start with the angle. So we can set up our equation as tangent of theta is equal to opposite over hypotenuse. So the angle would be the inverse tangent of 5.1 over 12, which is inverse tan 5.1 divided by 12 is getting 23 degrees. So that would be our theta. And then to find the magnitude of, or the speed of the boat, the actual speed, we would do the Pythagorean Theorem. So that would be, I can call that x. So x is going to be the square root 5.1 squared plus 12 squared, which is going to be getting 13 miles per hour. So that would be our speed of the boat and in this direction. All right. So there we have it. But actually they wanted to be written as a bearing. So we found this angle, which means we should actually look for this other angle. So these two angles are complements of one another. So we can find this angle by finding the complement. So the complement of 23 degrees would be 90 minus 23 degrees, which is 67 degrees. So we can say that the boat is traveling 67 degrees northeast is a bearing at a speed of 13 miles per hour. Miles per hour. And there we go. All right, let's move on to the next example. So we can also find the vector components of the components of a vector. If you have a vector that's maybe going in this direction, you can find the horizontal component, which is labeled as v sub x, and you can also find the horizontal component, which would be v sub y. And this is just trigonometry. If this is your angle theta, then the opposite over hypotenuse would be the sine of this angle, which would be vy over v. And if you solve for vy, then you would get this equation. And if you want to find the horizontal component of the vector, you would do cosine of theta, which is this divided by this. And then you would solve for v sub x, which gives you this equation here. All right, here's our example. The human cannonball is shot from a cannon with an initial velocity of 53 miles per hour. That's this vector here. At an angle of 60 degrees from the horizontal. Find the magnitudes of the horizontal and vertical components. So we're looking for v sub x and v sub y. And v sub x is just going to be, we can use our formula that from the previous slide, it's going to be adjacent over hypotenuse. And we know that the velocity has a magnitude of 53, so this would be 53 cosine of the angle, which is 60 degrees. And so that would be 53 cosine of 60 is 26.5. And then the vertical component, v sub y, is sine theta times magnitude. And that's going to be 45.9. All right, miles per hour for both of these. So that's how you would find those components of a vector. The next example, and this is going to be very similar to what we just did. Find the velocity of the arrow. Well, the velocity is just, we can do the Pythagorean Theorem here. So this is really 15 over here. We can move this to the other side because this is a rectangle, so these two vectors are the same. And so to find this vector, we would find use the Pythagorean Theorem, which is 15 squared plus 25 squared. The square root of that is going to give us a magnitude of vector v, which is 29.2 would be, and that would be in feet per second. That's the magnitude of the vector of the arrow. And let's see, what else do they want? Oh, that's all they're asking for in this case. All right. For this next example, they say Danny is 5 years old and weighs 42 pounds. He's sitting on a swing when his sister Stacy pulls him in the swing, and the swing back horizontally through an angle of 30 degrees and then stops. Find the tension in the ropes. So we're looking for T, the magnitude of T. All right, so let's see. We can actually draw a triangle here, a right triangle. Here's a tension of the rope. This is a horizontal force, and then the weight would be that arrowed there. So we can reconfigure these vectors in this fashion. All right, so let's see. There's tension that's being on the chain that's going in this direction. The weight is going in this direction, and Stacy's pulling her brother in that direction. So we want to find the tension in the chain first, or the rope, whatever it is. So let's see if we can figure this out. We know the weight of the boy is 42 pounds, so this is 42. Okay, and since we're looking for tension, we can do cosine. So cosine of 30 is going to equal to 42, or the magnitude of the weight, adjacent over hypotenuse. And so we can solve for tension. Tension is going to be the weight of the boy divided by cosine of 30 if you solve for t. And that's going to be 42 over cosine of 30, which is 48.5. 48.5. All right, so that would be the tension in the chain. And let's see, they also want us to find, what else do they want us to find? Find the tension in the ropes of the swing and the magnitude of the force exerted by Stacy. So now we got to find the h vector. Now that we have t, we should be able to find h as well. We can use opposite over adjacent this time. Tangent of 30 degrees is opposite over adjacent. And so the magnitude of vector h would be tangent, actually the magnitude of the weight times the tangent of 30. We know that the magnitude of the weight is 42 times tangent of 30 will give us 24.2. All right, so that is the answer to that one, and this would be in pounds. This is all in pounds. All right, let's move on to the next one. They give us another formula here. Work. The definition of work is a constant force is applied to an object and moves the object in a straight line and in a distance d. Then the work W performed by the force is given by the magnitude of the force. Basically, this is the horizontal component of your force vector times, this should be a multiplication, so I'm just going to put a little dot here, times the distance that you move something. All right. And theta is the angle between the line of motion of the object and the force being applied. So let's take a look at this example here. So this person here applies a force of 64 pounds in a downward direction. So this is the force vector. He's applying 64 pounds in this direction. So that's the magnitude of F. And he's going to move this box 25 feet. How much work is done? So we can apply this formula. W is equal to F with the magnitude of F times cosine of theta times the distance the object moves. So in this case, the force, the magnitude of force is 64 pounds. The angle is 35 degrees made by the horizontal line and the direction of the force vector. And we're going to multiply that by the distance that the package is being moved, which is 25 feet. So that should do it. All right, so let's see what the amount of work is going to be 64 cosine of 35 times 25, which is 1310. If you round up, that would be 1311. All right, and so that would do it. That's the amount of work. And this would be in units of, let's see, this is force, which is pounds, I believe. Yeah, pounds times lbs times distance, which is feet. That's the amount of work. All right. That does it for that. Let's turn our attention to our homework now. And for this, I am going to skip these, skip those. All right, for this first one, I want us to draw a vector representing the following velocity. 10 is the magnitude and in the direction of north, 60 degrees west. So this looks like it could be it here because this looks like it's 60 degrees. And it's going from north to west, which is the correct answer, actually. Right. Next example. All right, so here they're just asking us to find the two components, the vertical and the horizontal. To find the horizontal component, it's given by the magnitude of the actual velocity vector times cosine of theta. That's the formula. And then the other formula would be the vertical component, which is given by the magnitude of the vector times sine of the angle. So for the first one, we would get the magnitude is 12.2 and the angle is 22.4. Same thing for this one. 12.2 sine of 22.4. And if you do these, you will get 12.2 cosine of 22.4 is 11.3. And for the next one, they want two decimal places, so that would be 11.28, I should say. 11.28. And the other one would be 12.2 sine 22.4, which is 4.65. There it is. All right, let's move on to the next example. So for this one, if they give you the horizontal and the vertical components, you can draw a right triangle. and use the Pythagorean Theorem. So the horizontal component is 35, the vertical is 26, and we're looking for the hypotenuse. So that would just be the square root of 35 squared plus 26 squared, which is 43.6. They want one decimal place. 43.6 it is. And there it is. All right, the next one says a ship is 1.6 degrees off course. If the ship is traveling at 12 miles per hour, how far off course will it be after 7 hours? So for this problem, I would recommend drawing a triangle. So let's draw our triangle. Let's do this on a separate sheet. It's 1.6 degrees off course. So let's imagine a ship. Here's north, south, west, east. Imagine a ship is 1.6 degrees. This is not drawn to scale, by the way. Okay, so this is 1.6 degrees off course. And then the ship is traveling at a rate of 12 miles per hour for 7 hours. So 12 miles per hour for 7 hours. Is that right? 7 hours? Yes. So if you multiply that rate times time is equal to distance, that's going to be the distance traveled by this boat is 12 times 7, which is 84. So it's traveling 84 miles. And so we can draw this. Whoops, that's not really a right triangle, but let's just pretend that that's, well, I'll fix that. There's our right triangle. And so we want to figure out what x is, because that's how far off course this ship would be. And so we can find that by using our Pythagorean, our opposite of our hypotenuse. So sine of 1.6 degrees is equal to x over 84. So x is going to equal to 84 sine of 1.6 degrees. Let's see what that is. Getting 2.35 miles off course. So let's see if that is right. Yeah, and that's exactly what it is. All right, let's look at this next problem. A bullet is fired into the air with an initial velocity of 1,600 feet per second at an angle of 59 degrees from the horizontal. So let's draw that. So here's your horizontal. Here's the 59 degrees. The bullet is being fired. The velocity is 1,600. There's a right triangle. Find the magnitudes of this vector. So we're looking for that magnitude, the horizontal and the vertical components. And so to find these, we can just use opposite hypotenuse. So v sub y is going to be let's see, sine of 59 is opposite over hypotenuse. So let's write that out. Sine of 59 degrees is opposite over hypotenuse. And if you solve, you would multiply both sides of the equation by 1,600. That would be 1,600 times sine of 59, which is 1371. Round to the nearest whole number, so that would stay at where it's at. And so that would be the vertical. Let's see if that is actually the correct answer, which it is. And for the horizontal, you would do the same exact thing, except you would use cosine instead of sine. So I'm going to move on to the next problem. A ship travels 100 kilometers on a bearing of south 49 east. How far east and how far south has it traveled? So let's draw this picture. So there's your north, south, west, east. The ship is traveling 100 kilometers on a bearing of 40 southeast. So southeast would be this direction. All right. There's a right triangle. This is going to be 49 degrees. And we're looking at, this is going to be 100 kilometers. All right, so we're looking for the vertical components, south, and the horizontal component, east. So let's see what that is. So I'm going to call this Vy and Vx. So Vy, well, let's write our equations first of all. So I'm going to go with sine of 49 degrees is going to be opposite over hypotenuse. And then the cosine of 49 degrees is going to be adjacent over hypotenuse. If you multiply both sides by 100, that's how you get the components isolated. And then we can go from there. So Vx, the magnitude of that would be 100 times sine of 49 degrees, which is 75.5. They want us to round to the nearest whole, so that would be 75 kilometers. And that's V sub x, which represents the distance going east. So that would be the top answer. And then for the bottom one, you would do the same thing, but this time you would use cosine. All right, let's move on. All right, for this number 11, the horizontal and vertical components of the velocity of an arrow shot into the air are 16.3 and 24.3 feet per second, respectively. So those are your horizontal and vertical components. All right, so let's draw that. So your horizontal is 16.3, your vertical is 24.3. Find the velocity of the arrow. So for the velocity, we would just use a Pythagorean theorem. Absolute value of v is going to be 16.3 squared plus 24.3 squared, which is getting 29.26, and they want us to round to the nearest one decimal place, so 29.3, which is the correct answer. And then they want the angle of elevation here, so that's going to be theta. So for theta, you can do the inverse of tangent, and then you would do 24.3 over 16.3. So 24.3 is your opposite over adjacent. So that would be inverse tan, since we're looking for the angle. 24.3 divided by 16.3 is 56.1. And that's also in one rounded to one decimal place, so 56.1 degrees. There it is. All right, for the final problem, they're asking us a package is pushed across the floor for the distance of 75 feet, and the force is 42 pounds downward at an angle of 15. So here's your horizontal line, and the force is exerted in this direction at 42 pounds, and the angle is 15 degrees. How much work is being done? All right, so let's see. We've got to figure out the amount of work being done, right? So that's going to be, if you recall, work is going to equal to the force, the magnitude of the force, cosine of theta, times the distance is a formula. So here we go. The force is given by 42 pounds, cosine of 15 degrees, and it's being moved 75 feet across the floor, so that should do it. 42 times 75 times cosine of 15 degrees is 3042. They want us to round to the nearest whole number, so that would go up to 3043. Let's see if we're right.